here. All right. So a couple of these things, guys, are right in your book. And if you look at chapter 2, it talks about symbols that we're going to be using. We are doing dwelling. I really did. I used to, like I told you, I think dwelling is what, who's going to design dwelling? Until I talked to BKV, where Jamie is, and all what they do is an apartment, high-level apartments and homes. And there's a lot of knowledge in the residential. This is your chance, guys, with this book and this 7 weeks to know everything you need to know about dwellings, residential. The minute that we close these 7 weeks, we would never talk residential again. So we'll talk a little bit, guys, today. Identify and explain the electrical outlets, symbols used in the plans of single-family dwellings and multi-family dwellings. You can add. You're going to see a lot of symbols that we use. Remember, you guys are not, most of you, you're not licensed electricians. If you become a designers, you're not going to pick the material, though I am a firm believer as an engineer and a designer, the more you know about wiring, the better designer you will be. You're going to discover, especially if you work for electrical contractors. Discuss the type of outlet, boxes, luminaire switches that we use in residential. There's a couple of nice pictures. Mounting various electrical devices. When it comes to, for us engineers, guys, we don't go down to the methods of, we do the methods of wiring, but we don't go down to the material. What size of a screw do you need to mount this box to the wall? That will be the job of the electrical contractor. Now, remember, you could be that electrical contractor eyes and ears on the job. So as a project manager, then it would be really nice when you're standing right there in front of a bunch of electricians that you know what you're talking about. It's really, that's why we know it. Understand the preferred way to position receptacles, understand issues involving remodeling work and so forth. Um, Determine the maximum number of conductors permitted in a box. I'm going to do calculation for this one. That's residential, commercial, industrial, guys. As a project manager, Derek, when you become, your job is to inspect the electrical work before the inspector shows up. That's what a good project manager is. So if you know how the box fill calculation is, you can literally walk and look at any box, and just by the size of how many conductors, you can tell that this box is overcrowded. So that's not nice. Instead of the inspector come and make you change it and cost you more money. Fire resistor rating of walls and ceilings. We as electrical designers, guys, adhere to the NDC code book plus the building code book. So building code book will force you to put fire resistant outlets or material on your outlets if you are to penetrate right through a fire rated wall. So we get into the fire rated wall later on too. So that's a big thing in residential or non-residential. Okay, a little bit about the electrical symbols. You're going to see a lot of them, guys. We use them to indicate the location of our electrical equipment as receptacles or devices, receptacles and outlet and so forth. So that's it. You're going to see a lot of symbols that represent you tomorrow. I don't think we're going to do it today. Tomorrow, I will be loading all the symbols that we got from Ch02 Ericsson into your project. So you have access to all the symbols that we use. One thing you have to understand when we talk about an outlet, you're going to hear us talking a lot about an outlet, a point on the wiring system where we can utilize electrical power. So that could be a lighting outlet right above your head, directly fixture, directly connected to the power, sucking current out of the power, or it could be a power outlet right there where you can plug in your laptop or any other equipment to utilize the electrical power. We are in the power delivery method or systems, right? People hire us because they need to utilize our electrical power. That's why we have job, guys. Otherwise, if we don't deliver power, nobody will pay us. You are looking at three right in here. You guys are very familiar with that one. You're looking at three outlets. This is my so-called power outlet. This is my lighting outlet, and all these are points on the powering system that utilize electricity, use electricity. You're familiar with that one. The switches are not an outlet. They are devices. They're controlled, as you know, switches they do not consume by function electricity, right? They control the flow of electrical power. Okay, here you go. Devices outlet. So when you guys deal with the electrical industry, you always remember there's something called a receptacle outlet. There's something called lighting outlet. These are very important. Lighting outlet right above your head, directly connected lighting fixture to utilize electrical power. Receptacle outlet, you're looking at it right there in front of you. You're an outlet where you can plug something into a receptacle to utilize electrical power. So the key point between the two outlets is what? Utilization of electrical power. What does utilization mean? Using the electrical power. On the other hand, the devices are not an outlet. Devices are meant to control the flow of the electrical power and not consume electrical power. Now, Derek tells me, well, I have a switch that has a little light, pilot light on it, Chad. Well, that's meant for indication only. It will consume a little bit of power, but 99.99% of the function of a switch or a device is to control the flow of power, not to consume power. Cool? That's the difference between an outlet, a receptacle or lighting outlet, and a device. Any comments, guys? Any questions about these? So these are terminology you're going to hear people talking about. Receptacle outlet, lighting outlet, how many lighting outlets you can put in a circuit, how many receptacle outlets you can put in a circuit, three-way switches, four-way switches, and so forth. This is methods and material. Again, you guys will be engaged into this one. I'm sure, Karen, you guys have seen that one when you were with Karen. This will tell you when you are wiring with cables, the length of the wire as it enters from here all the way up cannot be less than 6 inches. Anybody knows why? 6 inches, and from the point it leaves the box right in here all the way, that one cannot be less than 3 inches. This is for termination. You guys as designers, we don't go down to this level, but remember, you're a project manager. You're walking around, and here's the apprentices terminating wires. They're doing roughing the boxes and putting their cables in, and they're making them very short. So that would be a good idea. The inspector sees them come to see rough in. Well, these don't make the inspection. So 6 inches from the point it enters the box, that will give you a slack so you can tie your devices and or your receptacles. Does that make sense? 6'3". I teach the exam prep for master and journeyman. I don't know if you guys know, and they test you on the state on all this. I mean, for you as a designers, it's FYI, it makes you a better manager. It doesn't make you a better designer, though. A better manager when you become a manager. Openings. There's a term called opening, guys. An opening could be a place where you have a lighting outlet, a receptacle outlet, a junction box, a switch. When I was doing, like you know, I grew up in Jerusalem. When I was doing electrical work there, and there's actually here too in Minnesota, when we estimate electrical power, some people estimate them based on how many outlets you have. So here's an outlet, or I'm sorry, opening. How many openings you have? So based on every opening is $50 or $40. So you count how many opening. An opening is a location for a receptacle, a switch, a lighting fixture. Count all these and multiply them by $40, and you get yourself an estimate for that particular project. So you're going to hear, if you work for electrical contractors, that this is some people use it to estimate the electrical cost of labor and material. Any comments, guys, about lighting outlets, receptacle, junction boxes? The generic term that they use to it is an opening. You know why they call it an opening? Because it's a hole in a wall where there's a box. That's what the opening is. That hole would be where you're going to tie this fixture in, or could be put a receptacle in or a switch. So that's the difference between receptacle outlet, lighting outlet, a device, and an opening. Opening encompasses all these three. Okay, luminaires. You guys will learn about luminaires more than you need even to know. You learn a lot of stuff. Luminaires is right above your head. It's a complete lighting unit. The diffuser, can you guys see that cover? That's called diffuser. It has a diffuser, right? Right underneath the diffuser, above the diffuser, you have the lamps. These are the source of the light. What drives the lamps is a ballast. We'll talk about the ballast that drives the lamps. And the ballast and the diffuser and the lamps, they're all housed into a housing, right? Can't just put the lamps right up in the air. So all these together make a luminaire or a lighting fixture. So when you hear the word luminaire, it's a box where you can, an enclosure where you put your lighting device, lighting element, the bulb, the ballast, if any. Some of them don't have a ballast. You have to have a junction box where you tie your branch circuit to it. And then you have to have, they have diffusers and reflectors. If you open this one, you're going to find sometimes they have a little reflector. Why do you have a reflector inside the enclosure? Reflect the light right above your head, right on the 2.5 foot level where you want to utilize the light. They call them reflectors. And then diffusers, it diffuses it evenly spread the light. The last 11 weeks, guys, you're going to spending it learning about lighting. So you're going to hear Chad talk tons and tons about lighting. Where do we put these luminaires? We have a software called Visual. We will be utilizing that Visual for commercial building to tell us exactly where we need to place these luminaires. In a dwelling, guys, very simple. In dwellings, every single room, habitable room, need one light. Where do you put that light? Right in the center of the room. Done. That's as simple as that. In a commercial building, we have software that helps us to do so. Okay, outlet devices, and junction boxes. All these guys have an article that talks about them. We'll talk about when it comes to the electrical devices and outlets and junction boxes, you have to put your electrical system in a box. Anybody, why can't we just splice up in the air? What's wrong with bringing two cables, splice them with wire nuts right up in the air above the suspended ceiling? They used to do that. What's wrong with splicing in the air? Why do we have boxes? The NDC code book require you guys, when you deal with electrical power, to use boxes and conduits and cables at all times. Every time you splice, you have to splice in a box. The idea behind splicing in a box is eliminating the possibility of fire generated from any arc or fault in the connection. The weakest link in any power system is the connection. Weakest link. The cable, highly unlikely, unless you go drill right through the cable, it's not going to arc. The arcing and sparking will happen with the weakest link, which is what? The connection. So that connection could create a fire. If the fire is inside the box, it will be contained and it will not spread and burn your building. That's the whole idea of having all your connection in a box. So if you're electricians, you find them splicing and throwing it right behind like they do sometimes, behind the sheetrock wall, splicing things, and the inspector is not there to push it right in the behind the sheetrock wall. Unaccepted in a box. And the boxes have to be securely mounted to wherever you put them. They can't be loose up in the air. They have to be securely mounted to a wall, ceiling, floor, whatever. And these are requirements from 300.5 state. Electrical boxes must be used and they must be secured. So that will give you why we use them. We will come back, guys, to the rules of sizing a box in details. And then there's a couple of boxes can be metal or non. The boxes that you can use is metallic or non-metallic. Almost exclusively when we're using dwellings, we use non-metallic boxes. When we go to commercial, almost always we use commercial, industrial, hospitals, you name it. We use metallic boxes. That's kind of the divider between them. Okay, so there's a lot of fittings, guys, and I'm going to spare you a couple of these fittings. Some boxes can be connected together. You can gang the boxes. There's a couple of examples we'll show you. There are many approved box mounting methods and hardware. If you're an electrician, that's where we do the apprenticeship. You guys want to go apprenticeship, so you learn all these methods and materials of mounting boxes with the hardware that comes to it. Like I said, I'm a master electrician wired in Israel and here, and I still struggle sometimes with certain wiring methods like bus docks and the hardware that comes with a bus docks. So you're going to spend, if you're an electrician, guys, you're going to spend all your life understanding the type of the hardware that goes. And if you think you know it all, you don't think a whole lot. There's close to 50 some wiring methods in an NEC code book. 50 some wiring methods in an NEC code book. And each one of these has its own fittings and boxes and mounting devices. And unless you brought cable busway, for example, unless you installed the cable busway, it's still rocket science to you when the first time you see it, right? You don't know what type of hardware goes with that. With experience, you probably will catch up with it. Boxes, when you mount the boxes, this is for project manager. A quarter of an inch back from the surface of non-combustible. You can set it back from, if it's non-combustible like sheetrock, up to a quarter and it's okay. If it's combustible like wood, they want you to flush it. And you know why? When you flush it with the wood, the likelihood that the fire will escape the box. Remember, the box is there to contain the fire. Contain the fire if it's to exist, contain it. So if there's a gap on a combustible material, the fire will escape and go burn your wood. If it's sheetrock wall or concrete wall and there's a gap of a quarter of an inch, that and the fire escape a little bit there, you're not going to burn that concrete wall or sheetrock wall in with that little gap. Does that make sense? Why they have this quarter of an inch gap sit back? So we sit it back a quarter of an inch. So this is FYI. When we do transition between, like I said, Karen, I don't know how many of you guys with us are done with that. I don't think you go more than probably 10 wiring methods that we go over, and we from MC to NM cable to AC cable to rigid conduit, EMT, PVC. That's what we do with you. Close to 10 of them that we actually make you work with them. We might talk about others. There are, like I said, 50 some wiring methods in an EC code book, and different ways of moving or transferring from MC cable into a PVC conduit or rigid into an EMT with the different fittings, and that's where a good electrician becomes. They're good electricians and better than good and excellent electricians. The people who know it have experience with it. So, for example, coming here, if you want to go, you're coming here with an extension like you can see here. You cannot bring a conduit and tap it from a box. The reason for not being able to do that when you're a project manager is because you don't have access. You cannot, this box, all boxes must have access to. So when you have a box that has a device or receptacle, you must provide access to this box. If you put a conduit this way, you cannot provide easy access to this box without basically altering the wiring method. And you're not supposed to alter the wiring method. You're supposed to take a couple of screws here, take the cover, and look at your outlet. So that's a violation doing it this way. This is the proper way extension. Did you guys do extension with us? When you extend the box, that comes very handy where you extend your boxes. You need to go from one concealed wiring methods into surface mounted wiring methods. Best way is to have an extension ring right there, tie it to it, and now you get you more room to extend it. Now, there's so many ways of doing this. That's why Matt and the ones who've done not the wiring, read this book, guys. It makes you, like I said, a better electrical designer by understanding the method that they use. Another way that they allow you to do it with a cable, can you guys see a cable like this, flexible extension? The reason why they allow you to do it with a flexible extension because you are to mount to support this one 12 inches from the box. So 12 inches will give you enough slack in a cable, not in a conduit, right? Give you enough slack so you can remove the cover. So that's an acceptable method. So, like I said, 50 methods of wiring. The more you know about these wiring, the better designer, the better estimator, the better project manager you will be. And hopefully we'll get you a few of them. Grounding and bonding. Grounding and bonding, guys. I have a sheet that I give you guys about grounding and bonding. That ground and bond a 4,000 amp switchgear, the highest they can get, with multiple generators, with multiple panels and so forth. But two things about grounding. We ground the equipment to facilitate the operation of the overcome protection device. So if Adam is to go change the ballast on this fixture and accidentally, the hot conductor here typically accidentally, is touching the frame of this fixture. This frame of this fixture is metallic, conductive. It's tied to an equipment grounding conductor. The circuit breaker will see this as a ground fault and will trip before Adam get electrocuted. That's a major goal of grounding the equipment. And we'll talk about grounding equipment versus grounding the system, guys, a whole different. Grounding the system, when you take a Y system is grounded. We ground it to stabilize the voltage to the ground. For example, you want to burn this at 120, you better go ground the system so it can get you 120. Meaning the Y, the center of the Y, has to be tied to the ground to stabilize the 120 that you're getting. Again, we'll talk about this one in details. Bonding and bonding, you have right above your head. Do you guys see all these suspended ceiling, right? All these metallic. What happened? Take this. What happened if a hot conductor touches the frame of this metallic suspended ceiling? Right? Could it happen? Look how many fixtures are right above your head. What happened if something like this accidentally happened? Now the whole frame, including this frame, become what? Energized. Waiting for somebody barefoot. Typically you have to be barefoot so you can join the Lord quick. You know, a perfect shock is a barefoot. To stand in there, grab with a hand on one side and maybe make it worse, touch that rounded object to the other side. Now you have a current going right through your heart. It will send you one ticket to the Lord. So that's why we do equipment around a conductor. So what do we do with this? We bond it. Then we bond that frame. The whole frame at one point will be bonded to the equipment around the conductor. So if that's to happen, the circuit breaker will trip. That's called bonding. Bonding the things that has nothing to do with electricity, like that grid. Really, it's just there to mount, right? To mount electrical equipments and all these tiles. But it's not meant to be electrical equipment. So we bond them. A tank sitting there that could be energized and have a pump on it. We bond it. So we bond them to facilitate the flow of the operation of the overconduction device, so it can save people. Like in dwelling, we talk about dwelling, guys. Almost everything is done with non-metallic. More economical. Why do we use it? Because it's cheap. Number of specific circuit, house wiring system, usually formed by a number of specific circuits. You're going to see when it comes to dwelling, the NDC code book talks and talks and talks and talks forever. They have everything that you need to know about the requirement for wiring in a for dwelling. Gang switches, guys, devices, multiple gang boxes. If it's non-metallic, 2, 3, or 4 gangs, you can see they can come in these, and you guys have seen them up to 4 gangs or so. They also marked with their cubic volume. Their cubic volume must be labeled on the non-metallic boxes, so you can do calculation for that one. The metallic boxes, you can gang them. Did you guys, the ones who did electrical work, you gang them, you put them together, right? Gang bunch of them, so you can gang as many as you want, up to 8, 10 sometimes, depending on the brackets that you have. Why do we gang them? Here you go. Here's a very good example of ganging. There's 1, 2, 3, 4, 5 receptacles. If I would use gangable boxes, I need 5 single device boxes ganged together to create room for 5 switches. That's what you're ganging as. Box mounting, required hold back, slow down the spread fire. So this is just why this article will tell you why do we care about putting a box. It holds back, retard, and slow down the spread of fire. That's the major reason that that we use it. Closing the gaps around the boxes reduces the spread of fire. That's why we want you that 1/4 of an inch. Remember that 1/4 of an inch to maintain not more than a 1/4 of an inch for non-combustible. Remodel. This talks about remodeling and fishing. If you're doing some remodeling, guys, they have the Madison hold it. You've seen it like this. If you're doing remodeling, I don't want to emphasize that one. These are the equipment you do remodeling, as you have to fish your cable inside the wall, and then you have to cut through the sheetrock to put a box, and then you have to mount your box to the sheetrock. These clamps or medicine hold it, they are the ones that you attach your box to an existing wall. Spread of fire. This little bit talks about the spread of fire and why do we put them all in the boxes. Building code. The other building codes, guys, also require you to do what the NEC code is doing. Do not install electrical boxes back to back. When it comes to the spread of fire, that's a big thing, guys. Thickness of the wall material must conform to the fire-rated wall. When you guys graduate from here, you're going to hear a 1 hour fire rated wall, 2 hour, 3 hour fire rated wall. That's how long will it take the wire to move from this location to the other location. 1 hour typically sheetrock, 2 hours or so double sheetrock the area. If you get into 2 and 3, you're talking about block and concrete walls. So that's where you 1 hour and so if you have a wall that's 1 hour fire rated wall, double sheetrock typically, then you in a situation when you penetrate, when you make a hole in it, you're supposed to maintain the integrity of this wall. For example, here's this side of the wall is a 1 fire rated wall. Can you guys see that? You're going to a none, and this one is not. And you're not to put 2 boxes side by side. Anybody knows why it's wrong with putting it here? What's wrong with putting it here? Right? So the fire, if you have a fire here and you have a wall, the fire will go directly from this direction or that direction, right? That will be a conduit for spreading the fire. You have compromised the integrity of the 1 hour rated wall. That's what you did. You compromised the integrity. So the smarter than Chad say, well, you can put one of them here and one here. So separate them, right? So in 2 stud spaces. That's one way, not back to back. We have a couple of other pictures, guys, that you do, and we have material that you put around them and so forth. Special insulation around wall penetration by cables, and you have to caulk the area. So if you're to penetrate through this fire-rated wall, you're supposed to caulk that area with a fire-rated material. So if it's 1 hour, the material that you put your conduit, and right around the conduit, you cover it with a 1 hour fire-rated seal or caulking. No gap. We talked about the no gap, 1/8 of an inch. You have to, if you have a gap, when you put your box, if your box, guys, is more than 1/8 of an inch away from the wall, you are supposed away, not sit back or forward, away slightly. Then you are supposed to go fix it. It's all about the speed of fire. Local electrical coordinates require metal raceways. Sometimes, like in Chicago, they require you to use metallic wireways instead of MC cable. Remember, how many wiring methods we have? 50 plus. So you can wire an outlet with an MC cable, AC cable, any other cable. In certain places, an M cable is not an approved wire method. 4-inch boxes with a trim plaster ring. So when they use conduits, typically we have square boxes that we use with them. There's a term yoke. A yoke, guys, as you're looking at the yoke right there, that receptacle is called the yoke right in here. This yoke can have 1 receptacle in it, 2 receptacles, 3 receptacles. So that's the yoke when you talk about yoke. 6 by 32 screws is the one that you mount them to the boxes. One way may have 1, 2, 3 or more yokes. So when you talk about a receptacle, special receptacle outlets, and I'm going fast through these one. These are the 240. Sometimes they have a 240, 20 amp or 30 or 40 amps for special equipment like ranges and so forth. We'll talk about these, guys. You will see it. Number of conductor in the box. I'm going to go over these guys, these 2 tables with you in a second here. These 2 tables in a little bit more details. I'm going to also talk about these in a little bit more details in a second here. And the box says height of the receptacles. I'll get back into the box fit in a second here. Height of the receptacle. The NEC code book, guys, does not specify how high the receptacles are in a dwelling or anywhere else. Other codes specify it, plus engineering practices. So the decisive factor for the height of the receptacles and switches is the American with Disability Act. American with Disability Act require you to put certain receptacles, certain height for disabled people so they can access it. So the building code also, for safety, require you to put certain things, certain height. So that's electricians. So where do you get these? From the plans and specifications. These specifications can be very engineers and architects and so forth. Here is a table. We'll look at the table in a second that has them. This slightly talk about the position. Not NEC rules exist on positioning. How do you position the receptacle? Did you ever wonder, guys? Sometimes you put the receptacle this way. Sometimes you put it this way, this way, this way. So which way is the better way? The NDC code book doesn't care. There's different ways. We'll show you different ways of, you can mount it any way, shape, or form you want. Okay, heights. These heights that you're looking at, regular. So if you have a switch, so you have 46 inches from finished floor is where they recommend to put it. 44 to 46 in kitchen cabinet, where you have if you have a kitchen cabinet in the area, 44 to 46. So it lowers it. Receptacles are regularly at 12 inches. These recommendation literally coming from the American with Disability Act. So people have access to these receptacles. Again, these are recommendations, so keep in mind. Between counter and kitchen, the height is 44 to 46. Garage, if you have a receptacle in the garage, recommendation 18 inches. Unfinished basement, 46 inches. Finished basement, 12 inches. Outdoor, 18 inches. You might, again, recommendation. In Minnesota, you might raise it 2 feet or 3 feet, maybe because of the snow. So again, these are recommendations for the height. But typically, that's what we do when we wire. Luminaires. You have an outside entrance luminaire, 72, right by the door, right above the door. Inside wall brackets, 5. That's like in the bathroom and so forth. So these are if you wire, or if you don't even wire, if you want to, these are good numbers to have as you wire. Did you guys go through this one with recommendation of height? So recommendation of height, it comes really very handy. So that's what I would like guys to go. What I have here, let me go over a couple of pictures here with you before. Okay, we talked about this one here. Talk about this. Okay, so receptacle outlets. We'll talk about receptacle outlets, guys. Okay, let me see here. There you go. So here's what we call it, lighting outlet. You can see very easily that the lighting outlet is a place where you utilize a lighting fixture in it. Here's your receptacle outlet. You can put a receptacle outlet right in here, so utilize the power. These are all symbols, and I don't want to go over all of them, guys. I want to remind you, Karen, I will give you a set of symbols that you guys are going to design the building in CAD. Now these are, ANSI has a set of symbols that the engineer can use. Every engineering firm, guys, have its own set of symbols. The first thing you need to do, Derek, when you went to Hallberg, is understand their symbols that they use and use them. I would say 80% of the symbols that you see in the industry are the same, but there's also 20% are different. But for the most part, 80% of them are the same. Okay, so what my expectation from you guys when you read this chapter is look at these. For example, surface-mounted incandescent lamps. Here's 3 ways of representing it on your drawing. And if it's wall-mounted, here's 3 ways of representing it. Any one of these is okay. Now, when you guys design for your friend Chad, they're going to find only one way you're going to do it, because that's the standard that we're going to be using. Does that make sense? Lamp holders with a pull switch, that's how we represent them. Recessed incandescent, fluorescent, look at the fluorescent. And again, this is bare lamp fluorescent strip. Surface or pendant exit, recessed exit, so junction boxes. These are FYI. Does that make sense, guys? Look at it. The symbols that you're going to use with me, it will be given them. You'll get yourself familiar with these. Because that's what you're going to be seeing for the most part in a lot of the projects. For receptacle, look at the receptacle, guys. Oops. For receptacles, we have single receptacle, duplicate receptacle, very common. This is clothes and dryer receptacles. We have a duplicate receptacle, a split wire. We have quad. Can you guys see the quad? Everybody knows what a quad is, right? For receptacle in one yoke. The clock, the exhaust fan, all these good stuff. And then symbols that we use on a plan. Like I said, you guys will have your friend Chad giving you the symbols. When we go to Revit, we also have a set of symbols that we use with Revit called families, already planned for us, and we'll be using them. Now, if you don't like, typically, like I said, 80% of them are the same, 20% of them change. That's where, remember the drafting that we did yesterday, and we said you cut and make a circle and all stuff to create these. Luckily, Every engineering firm has a set. If you don't go somewhere else and you need a set, I'll give you a set to start with. So you don't have to reinvent the wheel. The wheel has been invented. Switches. Look at the switches. Oops. Look at the switches, guys. We have single pole switch, double pole switch, three-way switches, four-way switches, door switch, dimmer. Um, do me a favor. What I would like you guys is to look at these. And if you don't understand what's a dimmer switch, a switch that dims. What's a three-way switch? A switch that turns things from two locations. Double pole switch, a switch that turns two hots, not just one hot. Low voltage switch. These are switches that work 24 volt. They're low voltage switches. So keyed switch. What is a key? Did you guys see the keyed switch, right? That you key it. Typically we use them in schools and so forth, so people don't turn the hallway light on. So we key it on and key it off. So for authority, occupancy sensor, we'll talk about these. So your job starting tomorrow, guys, is to familiarize yourself with the symbols that we have in our project. And also, please read these one and look at them. If you're not familiar, if you read something and you don't understand it, key operated switch or key switch with a pilot light, and you don't understand what this is, please talk to me. Because there's so many of them and you use them as you need them. Okay, a couple of things about the circuits. This is how we're going to do our circuiting. This is one way of doing our circuiting. You're looking, if you have two arrows like these, this indicates there are two circuits, circuit 1 and 2 here, going through, you're representing two circuits. The two hots here are representing hot 1, hot 2, the two slashes. The smaller one represent the neutral. That's how they do it. In our project, guys, we use it slightly different. We use actually the smaller two slashers here. We use them as hots, a bigger one as a neutral, and a bigger one with a dot at the end to indicate the ground. As long as you talk to the people when you design a system, you have a symbol list. The first thing you're going to do with your friend Chad is you're going to import a symbol list that we're going to give you guys. So if you don't know what this means, you're going to read and it will tell you that these are two hots and a neutral and two circuits coming into it. Okay, so the dots here are ground, two grounds here. Look at this, conduit concealed, conduit going up, conduit going down, conduit only, empty. So for future, switch leg, connect switched outlet with control points. So these are, please, I say please guys, look at them. You're not going to know each and every one of them, but be aware. That's why I would keep that book as a reference. These are the symbols that 90%, 95% of the people use in the industry. Again, you're going to get a couple of symbols very similar to these. For the project, you're going to be using the ones I'm going to tell you. So that's more and more guys symbols. There's tons of symbols. These are for alarm, smoke, and heat, and batteries, and buzzers, and data outlets. So disconnects, all these fans. Look at the fans over here. Grounding and TV and phone and so forth. So all these are lighting or power panel recessed. Look at the panel recessed, surface mounted panels, and so forth. When we go to Revit, you're going to see that when you grab a panel, it's going to be surface mounted panel. What is a surface mounted panel? You throw it on a wall. What is a recessed panel? In the wall. So these are the terminology that you need to know when we work with these equipment. Any comments, guys, about these? Does it make sense? The chapters are a little bit long, so please read them one time in your life. A couple of keynotes and notation. We call it keynotes. Later on, guys, you'll have a note like this with that diamond thing around it. And you would say, for example, it says, plug mold the entire length of the workbench, outlets 18 inches on center, install 48 to center from the floor, GFCI protected. So you have a mold, exactly like the one in front of you. They're describing a mold and what they mean on the plan. Derek, you cannot communicate enough with the people in the field. So if you have a mold, how are you going to describe to them what this mold is going to be mounted, that you want it GFCI protected, and you want the receptacle that says 18 inches on center. You're going to place them 18 inches on center. How are you going to communicate this information to the people in the field? You're going to use keynotes. So keynotes becomes very, very handy. We call them keynotes. We key the symbols that we did. Does that make sense? keynoting the equipment to give you more information about the equipment that you need. Split wire receptacles and weatherproof receptacle. Look at that. And sometimes we have notation next to it like WP, weatherproof receptacles. Weatherproof receptacles, you know what weatherproof receptacle is, right? In 2008, they stopped requiring the receptacle to be designed more robust. So if you put them outside or in a wet or in a damp location, the sun and the heat and the cold will not compromise the integrity of the construction of the receptacle. If you are an electrician and you worked here, guys, sometimes you go to a building to change the receptacle and you try to take the receptacle out and the whole receptacle falls right into your hand. It's disintegrated over the years. So that's what this is supposed to take care of it. So whether WP, weatherproof. Okay, here's a couple of, I thought these are very nicely done, guys, pictures. It will show you the fixture. Here's the symbol that we use. Here's how it looks like. And these are all the brackets, the way we mount them. So especially for you, Matt and Derek, if you guys have not wired like those guys have wired, this will give you an idea. Again, you're not going to be, we're not training you to be a wireman, remember. We will give you in a training and apprenticeship if we are. But the more you know, the better you will be. Especially when you become a project manager. If you go work for Ch02 Ericsson, care less about how it looks like. It really is. But if you know how it looks like, wouldn't it make that makes it put the two together and makes you a better understanding. Here's the recess, the cans, and you guys have seen these. A couple of outlets. Here's your single and two gang boxes. So what I like about this book that you guys have all these pictures. So if you're not familiar with something, please look it up once in your life. And remember, you have that 7 weeks to look at this. After that, we'll close this chapter, we'll move to the commercial. You wouldn't see these again. A lot of these are direct, especially the non-metallic. Everything non-metallic is directly related to residential for the most part. This is my favorite. And I really like the way the author did that one. Do you guys see the symbol that we use on our plans? That's how it looks like graphically. You need a cover for it on a box, right? When you guys start doing estimating with your friend Chat, and I want you to take off this receptacle, this switch. You need to take off the cover, the switch, and a box. That's called assembly. We call it an assembly. This is how we operation symbol in the control on-off. This is how you put it in a circuit if you guys have not wired. So this is this looks like a single pole. This is my double pole. Can you guys see you're breaking two hots or a hot and a neutral? This is three-way switch. This is the wiring method for a three-way switch. This is your four-way switch. This is a pilot. All these are wiring methods. As you guys move with me in this chapter, you will be required to go and draw these for wiring methods. You're not going to be wiring. I'm not saying you're going to be wiring. If you guys, I know you guys wired. I hope you know how to do 3- and 4-way switches. I really do. Otherwise, we're in trouble. If you want to wire an actual wiring 3- and 4-way switches, I will take you to one of our labs, the one who have not done, and we can wire them. Do you understand? But you need to understand, though. We'll have a few of these that will help you understand them. Okay, connections, guys, and termination. We'll move into that one extension. This is just talk about the hardware. Look at that. Now we're transferring from EMT into an AC. If you're a good electrician or a good electrical manager, you should know that there's a fitting that takes you from one wiring method to another, right? So that's what, with the experience, you guys will be, you understand all that one. Boxes, equipment and boxes and so forth. We talked about the methods of extending. This is not acceptable. This is acceptable. A cable. Anybody knows why the flexible is acceptable here? Because you can take these screws here, bring it down. Since it's a cable, it's flexible, so you can open the cover. So these are a couple of methods to do different boxes, metallic switch devices, and non-metallic boxes that we use. Here's the gang, 2 gang, 3 gang, 4 gang. You guys are familiar with that one. Nice pictures for different gangs. Okay, this one we'll talk about the box fill. I'm going to show you guys in a second. Here's a box fill, single gang box, guys. Wire size, here's the sizes that we have. Box selection guide for boxes generally used for residential. For example, if you're using number 12 conductor in a single gang box like this, and your box is 3 by 2 by 1.5 inches. How many conductors can you bring to this box? 3. Can you see that? If your box is the deep box, 3 by 2 by 3.5, how many conductors you can bring to this deep box? 9. 9 conductors. So that's what they call a box fill calculation. When the inspector walks around, guys, rough in, they look at the box. Based on how deep the box is, they can tell you easily, oh, this box is crowded. How do they know? From these sheets. It's crowded or not crowded. And of course, there will be a device yet added. So that's how we use this one. Look at this. Here's a square box. The square box, it's a 4 by 4 by 2 sizes, say 2 and 1/8. I can bring 13 number 12 conductor to it, or 15 number 14 conductor. When you're dealing with devices for dwellings, you're dealing with number 12 and number 14 almost all of the time. 12, 14, 10, maximum 8. That's the 3 sizes that we're going to be using in this book. We're going to 14, 12, 10, and 8. That's about it in terms of branch circuits. Okay, any comments, guys, about these? Comments? Raised cover will give you more if you put raised cover. Masonry boxes also give you how many conductors if you bring them in the masonry boxes. And masonry boxes have lots of room available, up to 6 gangs and so forth. So this will give you the box fill calculation that I'm going to do shortly. Okay, we talked about sit back, guys, the gap that you can sit back a quarter if it's non-combustible, flush if it's combustible. The area, can you guys see that area? As a project manager, you should go inspect. So this area, if it's more than 1/8, what are you supposed to do with that? Go cover it. Adam, did you guys use these pictures when you did? Okay. So they're really very common, very nice pictures. Mounting brackets when you put your receptacle right in the middle of it. And so these are different mounting brackets, these are for retrofit, different brackets that you can do retrofit. We talked about, guys, the fire rated walls. You don't put them side to side. Also, when you're doing apartments, you don't put a receptacle back to back. Why do you guys don't, even if it's not fire rated wall, why don't you put them back to back? Noise. Because the noise transfer from apartment 1 to apartment 2. So what they do is they separate them. They put every device in every cavity. Does that make sense? So because the noise will transfer between these two, even though if it's not fire rated wall. So there's a few things that we use also for noise. This is how the solution is. You have to put like this. This is putting this bracket to maintain the integrity. Or, can you guys see the other solution is? The other solution is to put that little putting over it to maintain the integrity of these equipment. Or you can space them away from each other. So these all are methods. Here's the material that you put around the equipment. We use some of these, guys, also for environmental reasons, for energy saving and so forth. We talked about if you have a raised cover like this, guys, will give you a little bit of cubic inches when you do your conduit sizes. And I'll talk about the conduit sizes in a second. That's all we're going to do. I'll talk about the conduit after I give you guys 5 minutes break. Any comments, any questions about that? So that's what we're going to be doing, basically. Please read them. Please look at the symbols. Look at the stuff that we have. That will make you a better residential designer. Because when we open another chapter, I'm going to complete the commercial afterwards. Okay, I'm going to give you guys 5 minutes, stretch 7 minutes, and then I'm going to do a box fill calculation problem.